Hey everybody, it's Dr. B. I am going to go over a little bit, one section of the organic acids test today, so hopefully it helps everybody understand why this is so important. The first thing we're going to cover today, or the only thing we're going to cover today, is the fatty acid metabolism. So when we look at an organic acid test, especially from Genova, you're going to see the fatty acid area. There's three markers, adipate, subrate, and ethyl milani, that are on there that give us an indication if fats are being burned appropriately and going through beta oxidation inside the mitochondria. So when we take a look at these three markers, let me explain how they come about. We have fatty acids that we want to burn inside the mitochondria. That's the primary fuel for almost every tissue in the body except for brain. And so we need to get fatty acids from the periphery into the cells. And so lipoproteins transport the fatty acids to the cells. B5 helps get those fatty acids inside the cell. And here's our fatty acid. Fatty acids then need something called the Carnitine Shuttle to get the fatty acids inside the mitochondria. The fatty acids can't get through the mitochondrial membranes by themselves, so they use a shuttle called the Carnitine Shuttle. So carnitine transports the fatty acids into the cell. So over here is the outer membrane of the mitochondria. Here's the inner membrane of the mitochondria. Here's our carnitine. Here's our fatty acid, our acetyl-CoA. And acetyl-CoA plus the carnitine go through an enzymatic reaction with the CPT1 or CAT1, and that's carnitine acetyltransferase. And that reaction creates acetylcarnitine. Acetylcarnitine can then work its way through the outer membrane and into the inner membrane area via a translocase protein. Once inside the inner membrane of the mitochondria, it goes through a second reaction with CPT2 or CAT2, and that cleaves off the carnitine. Now we're left with acetyl-CoA that can go into Krebs cycle, and the carnitine just works its way back outside the mitochondria so it's ready to bind with another fatty acid. That's the primary way to get fatty acids burned inside the cell. It's called beta oxidation. It goes through a process called beta oxidation. We go through Krebs cycle. However, if I don't have enough carnitine, then the carnitine shuttle will not work. So I get a block here, and so the fatty acids get into the cells, but they can't get into the mitochondria, and so the fatty acids are then shunted off to the peroxisomes, where they go through what's called gamma oxidation. And gamma oxidation provides some energy, but not near the same amount of energy. And the byproduct of that is two metabolites called adipate and subrate. So if you're looking at your organic acids test and you're seeing elevated levels of adipate and subrate, you know that I'm not getting fatty acids into the cell, inside the mitochondria as efficiently as I should, and it may be because somebody's got a carnitine deficiency. There are other factors. Anything downstream in the Krebs cycle that's not working will back the whole process up. This process is very FAD dependent, and for those that were at the Methylation and Madness seminar, you learned that FAD is the activated form of riboflavin, and the tie-in to that with patients who have hypothyroidism is you need adequate levels of free T4 to activate riboflavin into FAD. Okay? So the other marker that's on here is ethyl milani, and ethyl milani occurs because intestinal bacteria can make a fatty acid called butyrate, and butyrate can be used to burn inside the mitochondria as well. But the butyrate needs the carnitine shuttle. So if the carnitine shuttle is blocked, I can't get the butyrate inside the mitochondria, and I get butyrate building up. Butyrate then can go through a different enzymatic reaction and be converted into something called ethyl malinate. And so if you see elevations of all three of these guys, if they're all elevated, we know that we've probably got carnitine deficiency. We may have decreased FAD. We may have decreased NAD. We've got a problem with Krebs cycle somewhere, and it's backing this whole system up. So hopefully that helps you. That's the fatty acid metabolism on the organic acid test. If you have any questions, put them in the post below this on the board. All right? Thanks.